Hello and welcome to this lesson. In this lesson, we're gonna go over the physical layer. Before we discuss the physical layer, let's go through the LAN and WAN. LAN stands for Local Area Network and WAN stands for Wide Area Network. As you can see in our example, we have a branch in New Jersey. In this branch, we have one router, one switch, and two devices or two end devices. So when we talk about LAN, we're talking about our internal devices which are located in one physical location and controlled by us or controlled by our network engineer. So when Jack and Bob send the data to each other or using the internal network, this is called LAN. Also, as we can see, there is a connection between New Jersey branch and Tokyo branch. So when Jack send data to Chris, this type of connection called WAN, or this type of network called WAN. So the WAN is going to be the outside network that provided by company called ISP. ISP is the internet service provider, and ISP provide internet for user and also provide connectivity between branches. The ISP network will not be controlled by us, and we will not have any idea about how many devices, how many routers in this network. So this is called the WAN network or WAN connection. The speed of the cables will be by kilobits, megabits, and gigabits. Kilobits is 1024 bits, megabits is 1024 kilobits, gigabits is 1024 megabits. So how large is our LAN, or how many devices in our LAN? The first type of the LAN we have SOHO, small office home office LAN, and this is a small type of network. In this network we'll see a limited number of network devices. As we can see in our example, we have one switch, one router, one access point, or it could be more than one access point, and multiple end devices. But when we move to large offices or companies or branches, we're talking about enterprise LAN. An enterprise LAN is a medium size of network. In this network, we will have multiple floors. Each of floors will have multiple devices and will have a switch connection. So each of those floors will have a dedicated room for the network equipment, and this room should be secured. So let's move to the physical component. The physical component, the first thing when you hear media type, we're talking about the connection and the physical component. So what is the media type we can see in our LAN? We can see Ethernet cable, fiber cable, SFP, small form factor, pluggable trend receiver. So the fiber cable will come with one pair of cables, one transmitting data and one receiving data. We have also DAC cable, direct attached cable, NIC, network interface card, and the NIC for switch, we can call it port card or blade. So in this switch, the left side ports are Ethernet ports, and the right side we have 9 and 10 are Ethernet, 11 and 12 doesn't have any port. So in case of any of the right side, the Ethernet ports damaged, we have to replace the whole switch. But for 11 and 12, we will plug the SFP inside it. So in case of the SFP goes down or damaged, we can replace the SFP. So the SFP give you the flexibility, it's removable. We can choose between multiple speeds. We have a 1 gig, 10 gig. There is a fiber SFP, copper SFP. We can use also the DAC cable because the DAC cable has a SFP on both ends. So SFP is the most appropriate connector in the network. This is a picture of Ethernet cable, and the right side picture is RJ45. So the Ethernet cable can come as a copper or fiber. The copper transfer electricity, the fiber transfer light. Inside the cable there is a 4 pairs as we can see, and it's colored. Each one of those cable will go inside the RJ45. There is a position for those cables, and it called bins inside the RJ45. The Ethernet cable is a standard cable, standard from IEEE, and all the cable types of Ethernet start with 802.3. It comes shielded and unshielded, shielded twisted pair and unshielded twisted pair. The shielded twisted pair used in case of if the Ethernet cable will run next to a power cable, because the power cable will affect the Ethernet signal. So we have to choose the shielded twisted pair. Those are some types of the Ethernet cables. We have Ethernet, Fast Ethernet, Gigabit Ethernet, and 10 Gigabit Ethernet. The Ethernet is 10 megabits per second, the Fast Ethernet 100 megabits per second, the 10 Gigabit Ethernet is 10 gigabit per second, and those are the IEEE standard names, the formal names, and the maximum lengths. So for most of the copper cable will run up to 100 meter. If we have a distance larger than 100 meter, we can use the fiber, because the fiber can run up to 5000 meter. So let's start with the 1000 base T cable. The 1000 base T cable will use the 4 pairs of cable to transmit the data and receive data simultaneously. So it will use all those cables to transmit and receive data. But for the 10 base and 100 base cable, those type of cables will use only 2 pairs to transmit and receive data. The connection of those 4 pairs can be straight through or crossover. In the straight through cable, we will connect the pins with the same cable. So if we connect stripped greens in one side, we will connect stripped green on the other side, so on. The straight through cable can run between desktop or computer and switch. And the reason of that, because the computer will transmit, TX stands for transmitting. So the computer will transmit the data on 1 and 2 and receive data on pins 3 and 6. The switch on the other side is receiving data on 1 and 2 and transmitting data on 3 and 6. So the straight through cable will work between those devices. But what about if we're going to use a switch and switch connection? In this case, the straight through cable will not work, because if we connect pins 1 to pins 1 in the other side, it will receive a data on both ends and will not gonna work. Same thing for 2, 3, 6. So for that case, we can use the crossover cable. In the crossover cable, we will connect 1 and 2 in one of the RJ45 pins to 3 and 6 in the RJ45 connector pins on the other side. And then 3 and 6 in one of the RJ45 pins to 1 and 2 in the RJ45 other pins. And then we will connect the rest of the cable as a straight through. So 4 to 4, 5 to 5, 7 to 7, 8 to 8. As you can see, the router one of the switches will receive data on 1 and 2, and the other one transmit data on 3 and 6. The other side of switch will use 3 and 6 to transmit data, will goes to 1 and 2, which is the other switch receiving data on. Those are the different types between the transmit and receive data pins on the devices. We have desktop or computer. We have router access point transmitting data on pins 1 and 2, receiving data on 3 and 6. And the other devices are switch and the hub, transmitting data on 3 and 6, receive data on 1 and 2. So if we will connect the devices from the same category, we have to choose the crossover cable. If we will connect desktop to router or desktop to access point or router to access point, we have to use the crossover cable. But if we will connect one of the devices from one category to another device from a different category, we will use the straight through. So if we will connect switch to the computer, we will use the straight through. If we will connect router to switch, we will use the straight through. If we will connect switch to access point, it will be a straight through also. There is a feature also on the switch called the Auto MDIX, and this feature allows the switch to automatically change its transmit and receive pins based on the other end. So if the other end, regardless what device it is, transmitting data on 1 and 2, what will happen is the switch will automatically receive data on 1 and 2 and transmit data on 3 and 6. So this feature called Auto MDIX. So what will happen if we receive the data on a serial cable? So the right side cable is a serial cable, and this data encapsulated in HDLC frame. This data should be forwarded to another switch, which is connected with our switch with an Ethernet cable. In this case, what will happen? The data will be rewritten on the switch and encapsulated to the frame. So the encapsulation will happen based on the next hub in order to transmit the data correctly and match the cable requirements. The previous cable types was about the copper cable. So what about the Ethernet fiber cable? The Ethernet fiber cable use a fiberglass, and the fiberglass is different than the window car glasses. The fiberglass is way flexible, but you have to be very careful when you bend it, because if you bend it hard, it will damage the cable. The core is the cable that transmit the data, and it's protected with 4 outer layers to provide more security to the core. So the fiber cable is faster than the copper cable, and fiber cable can support more length or longer length than the copper cable. The fiber cable comes with 2 types, comes with a single mode and multi-mode. The multi-mode will be used in a short distance, and the cable itself or the core itself reflect light. So the source light for the multi-mode cable will be a LED, and when the light reaches a core, it will reflect it and will not go in a straight line as we can see in our picture. This type of cable is inexpensive. We have also the single mode. The single mode support longer distance because the cable run in a straight line, and the source light for the single mode is a laser. This type of cable is expensive. Those are some standard cables for the fiber and type of it and the maximum distance. We have the 10G base S. This is a multi-mode, can run up to 400 meter. There's the 10G base LX4 multi-mode, can run up to 300 meter. There's also the 10G base LR single mode, can run up to 10 kilometer. 10G base E single mode can run up to 30 kilometers. This is the end for this lesson. I'd like to thank you and see you in the next one.